Now we will enter into a stage when we will focus on the 7 tools of quality. Okay, there are 7 tools of quality which are which have been used for a very long time. Okay, which has a huge impact on majority of the problems that we are working on, and which we will be able to focus on. These are not the hypothesis tools. These tools will not give us any kind of statistical influence, but yes, these are good enough tools which help us to make a sort of a decision to move to the next level. Okay, so in Six Sigma Green Belt sort of a project, we rely on the 7 tools of quality, and in the Black Belt we use a combination of both the 7 tools as well as the hypothesis test. Okay, so that's why these tools are very, very important. The name of this tool has come from Ben Kay. Okay, he's a gentleman. He was a warrior who owned 7 weapons, which he used to win during all the battles. Okay, and from there this seven word comes from, and wherein in Six Sigma in quality, the 7 best tools have been categorized, listed, and it has been proven that if we work on these 7 tools with full focus, we can resolve 95% of the problems that we are currently facing. Okay, using these 7 tools. So that's why the 7 tools of quality are very, very important. So let's look at what are these 7 quality tools. The first 7 quality tool is Pareto. We will talk about it in detail about Pareto analysis. Then it's a histogram, okay, a scatter plot, cause and effect diagram, fishbone, which we have already covered. Okay, fishbone is also one of the 7 quality tools which we discussed already. Flow chart, it's like a step-by-step, it's like a process map.
Process flow.
Yeah, process flow, which we kind of covered as well, but yes, we'll discuss in detail here. Check sheet, we'll discuss that as well. And control charts. Okay. Control chart is somewhat we will be covering in the control phase when we will help you plotting the different control charts. So, and there is another one new addition to the list which is called data stratification. That's the 8th one, but still we call this as a 7 quality tools because that's a standard that has been followed. But because data stratification also help us to look at the problem in a different sort of way. So these are different tools of quality which help us to resolve at least 95% of the problems. Okay, so we will cover these tools one by one. We will take we'll also learn how to apply these tools on Minitab as well. The first tool which we're going to talk about is the Pareto analysis. Okay, I'm sure majority of you have heard of it. So anybody would like to talk about what is Pareto analysis?
Pareto is 80-20 analysis where we say that the 80% of the problem happens because of 20% of the cause majorly. Or in certain cases, we also say 20% of the remediation fix 80% of the problems. So that's the high level of Pareto chart, yeah, that is what I know.
Okay. Anybody else want to share any example of Pareto analysis? Anything which you can lead to Pareto analysis?
Like 80% of wealth which is occupied by 20% of
people in the world.
Population.
Absolutely. Okay.
20% of the factors impacting the 80% of the problem.
Okay. Okay, so 20. So can I say 20% of my defect is contributing to 80% of the total defects?
Yeah.
Right.
Yes.
Okay. Can I say 20% of the people are contributing 80% of the errors?
Right.
Can I say 20% of my product, because of 20% of my product, my customer satisfaction score is impacted by 80%. Okay, so it's a 80-20 kind of a rule, which helps me to prioritize some of the reasons of failure or reasons of defects so that I can focus on. So usually typically what happens is if I have too many reasons, okay, it is not possible for me to work on all of them together. So therefore, Pareto analysis helps me to look in those vital few causes which I'll be working on. I'll be able to resolve majority of the issues. Okay, approximately 80% of the issues. That's what my Pareto analysis talks about. So, as we said, Pareto works on the 80-20 principle. It states if you work and correct top 20% of your problem, then 80% of the process can be. Okay? This can be used for looking at the defects, top defects. This can also be used at looking at the top people or top departments who are producing a lot of defects. This can be used for different categories. There is one ground rule. Pareto analysis is only to be used when your data is discrete in nature, because you know there are a number of occurrences that would be mentioned, and that's how you'd be able to use the Pareto analysis. Let's do a Minitab hands-on, and then we'll have more questions also. So just give me a second. Can you see the Minitab screen now?
Yes.
Yes.
Yeah.
Okay. So I've typically collected the data. So let's say I'm doing a project on improving the productivity, and there is a team who's maintaining this data, or probably they have done some survey with a team and try to identify the voices. And this is that we have captured this data wherein some people said that they are not properly trained, poor coordination, no R&R, attrition, low salary, poor planning, less manpower. Okay. Now I want to draw a Pareto and identify what are those top reasons that if I am able to work upon, I'll be able to resolve majority of the issues. Okay. So to do that, so I've just pasted this data from Excel to Minitab. Okay. So I'll go to stats. I'll go to quality tools. I'll go to Pareto chart. Okay. So here in the defects or attribute data, okay, I will mention the attribute, the reasons which are mentioned. In the frequency, when you saw frequency is the number of occurrences, I mentioned the error. So this is the header that I have given. You can give any header of your choice also. Okay. And then you click on OK. So this is how a Pareto chart is being prepared in fraction of seconds. Okay. And now with the help of this, you can see that these first three causes, untrained manpower, poor coordination, and no R&R, is contributing to 77.7% of the reasons. So if I would have not prepared the Pareto, I probably have randomly started working on the low salary. Okay. I probably would have worked on less manpower. These first three contributing to 78 approximately, and these four, or maybe the other one which I've taken, is contributing to 22. So which of them would you like to focus on?
The first three.
The first.
First
The
three.
first three.
Okay. So this is the power of Pareto analysis. It's a wonderful tool. Can be used in a Six Sigma project, can be used when you typically face any sort of a problem and you want to prioritize it. Because typically when we face any kind of a problem, we do not look at that point in view. We never look at resolving it. So whatever people say, we start capturing it, we start looking at it. But if we prepare a Pareto chart, Pareto would give me an indication that which of these tools, which of these areas that I'll be working on. Okay. So likewise, I can click on it, I can copy graphs, and I can paste it wherever I want to, and I can see this is being pasted. Okay. So this is what we can do with the help of a Pareto analysis. Anybody has any question on the Pareto chart or Pareto analysis?
No.
No.
I think it's pretty simple. So in the slides that I'll be sharing, I have already mentioned the Minitab path. So you can refer that, stats, quality tools, Pareto chart. Okay. The second tool that we are going to talk about is the scatter plot. Okay. A scatter plot, there is a prerequisite. Okay, scatter plot is to be used when you have more than one variable. When
More than
this
one?
help more than
Variable.
one variable. When you have
Okay.
at least two variables to compare, maybe an x or a y, okay, to establish the relationship. So it tells us the relationship between two variables. So scatter plot help me to identify whether the x, what sort of a relation x and y has. Okay, it's a very important tool, this which give us the direction of the correlation between two different variables. It tells me whether what sort of a relation between two variables is. Okay, uh, we can interpret the scatter diagram with the R value. Okay, so there is an R value that is being calculated using certain formula, which we can do it with the help of a scatter plot. So for example, you have a Y which is productivity, okay, and you want to compare it with the attrition. So now you have two variables. Now you want to look at what sort of a relation this two variable is. This is to be done with the help of a scatter. Okay. So it can either have a positive correlation, it can either have a negative correlation, or it could have no correlation. So let's understand the difference between positive, negative, and no relation. Positive relation is if one variable increases, another variable also increases, or vice versa. If one variable decreases, another decreases. So in a nutshell, if both the variables move in the same direction, if your, let's take an example of temperature and ice cream. Okay, if your temperature increases, the sale of ice cream also increases, and if the temperature decreases, the sales of ice cream also decreases. So this is a positive correlation. Okay, because both are moving in the same direction. That's a positive correlation. What is negative correlation? Negative correlation when one variable increases, another decreases, which means they are working in an opposite direction. So for example, weather and sale of a jacket. So if my weather increases, my sale of jacket decreases. If my weather decreases, my sales of jacket increases. That's our example of negative correlation. When one variable and another variable has a negative sort of correlation. Okay. Then the third category is called as no correlation, which means no matter whatever happens, there is no sort of correlation. Okay. So to understand it better, there are certain significance that has been given. Okay. If the R value is between 0.4 to 1, we call it as a perfect positive correlation. It's a positive correlation, but we call it as a perfect because it is the R value is good enough. If it is 0.2 to 0.4, we call it as a moderate positive correlation. If it's between 0 to 0.2, we will call it as a very weak positive correlation. Anything which is less than 0 or maybe in negative, that's a negative correlation. Okay, and anything which is between 0.1 to 0.5, it is a very limited degree of correlation. So this is to be calculated with the help of a R value, wherein we would be able to plot whether the scatter diagram that I prepared, what sort of a correlation is this. Okay, so let's do a minute. Anybody has any question? Yeah.
So just a question. For the moderate correlation, we are saying we consider values from 0.2 to 0.4. And then again, in a limited degree of correlation, we are saying 0.1 to 0.5.
Okay. The reason behind that is because there is a very thin line difference between 0.1 to 0.5. Okay. It is not an industry standard, but yes, we would never be calling it as a moderate or a limited degree. We would either call it as a positive or a negative. But yes, if it's between, rather we should not have a limited degree of correlation. I would remove that from the list. It should be either perfect positive or a moderate. Okay. So anything which is lesser than 0.2, it's a weak correlation. Okay. So I would make that change. So
Thank you.
perfect. Okay. So perfect positive is we always should aim for, because the strong relation it has, it would have a strong impact on it. So let's do a minute of hands-on exercise and see that what sort of correlation that we would be able to plot with the help of scatter plot graphically. Okay. So give me a second.